So if we want to see parallel lines, we need to look at the gradient. Remember when we did the gradient intercept method or slope intercept method, we said that this number that comes in front of x, that is called our gradient. And lines are parallel if they have the same gradient. Let's look at an example. The graph of y is equal to 4x plus 1 and the graph of negative 8x plus 2y is equal to negative 4. Are those two graphs parallel? Well, we've got to check, is this number in front of x in both of the equations the same? If that number, that m value, that gradient, if that is the same in both lines, then these two lines, these two graphs here, are going to be parallel. Well, the first one is written in the form of y is equal to mx plus c. So in y is equal to 4x plus 1, I can read off the gradient is 4. But in the second equation, I've got to rewrite it in the form of y is equal to mx plus c, so that I can read off this m value, this gradient. Well, let's start. So that's 2y is equal to this negative 8x must come over and become positive 8x minus 4. Divide everything by 2 so that we have y by itself. Divide everything by 2. And now I can read off in this graph, the gradient is also 4. And because the gradient in both graphs is 4, then these lines are parallel. If you ask a question like this, if y is equal to 4x plus 2 is parallel to y is equal to ax plus 7, what is the value of a? Well, let's write those two equations down. Y is equal to 4x plus 2, and the graph of y is equal to ax plus 2. We're told those two lines are parallel, then the gradient has to be the same in both the graphs. So if it's 4 there, in this graph, it must also be 4. So a then is 4 because those graphs are parallel. So parallel lines have the same gradient. It must always be written in the form of y is equal to mx plus c. You rewrite your equations so that you can read off the m value, and if the lines are parallel, then the m value must be the same, which means the gradient in both graphs is the same if lines are parallel.